Welcome to episode 126 of George's Random Astronomical Object. Every episode, I run a random number generator to select random astronomical coordinates in the sky, and I then search for an astronomical object near those coordinates and talk about what makes the object so interesting to astronomers. So I will now run the random number generator. This episode's coordinates are 19 hours, 25 minutes, 9.6 seconds for ascension, and negative 66 degrees, 28 minutes, 8 seconds declination. The coordinates for this episode point to a location in the southern constellation Pavo, which is supposed to represent a peacock. This was one of 12 constellations invented in the 16th century by two Dutch navigators named Peter Dirkzoon Keizer and Frederik de Hoytman to fill up what had previously been an uncharted part of the southern sky, at least from the European perspective. A peacock seems kind of random, but apparently Keizer and de Hoytman liked naming random patches of stars in the sky after random animals they encountered in the tropics. The specific object this episode's coordinates point to is the star system HD 181433, which is located at a distance of 88.1 light-years, or 27.0 parsecs. The single star at the center of this system is a ho-hum red dwarf, with an age of about 6.7 billion years, making it about a couple billion years older than the Sun. However, the one notable thing about this star system is that 3 exoplanets have been detected orbiting it. The discovery of these planets was published in 2009 based on observations performed in the early 2000s. Two common techniques are used to detect exoplanets. One technique involves watching for the faint dimming that occurs when planets pass in front of the stars that they're orbiting. But this technique only works if the orbit of the planet is aligned in just the right way for this to happen. The other technique involves looking for the slight periodic Doppler shifting of light from a star that would indicate the planets are orbiting it. And while this is more time-consuming to do, it's generally more effective at detecting planets because the orbits of the planets do not need to have any specific alignment. It's this second technique that was used to find the exoplanets orbiting HD 181433. The 3 exoplanets are labeled HD 181433, B, C, and D. Exoplanet B is what's called a super-Earth, which is a class of exoplanets in between the size of the Earth and the size of a small gas giant like Uranus or Neptune. It's about 7 times the mass of the Earth and orbits its star once every 9.4 days at an average distance of 0.08 astronomical units, or AU, where 1 AU is the distance from the Earth to the Sun. A super-Earth might sound very exciting, but astronomers have discovered a lot of super-Earths at this point, and HD 181433b is so close to its host star that it's too hot to harbor life. And it's actually not that interesting. So I'm not going to mention this exoplanet again during the rest of this episode. Exoplanets C and D are both gas giants. C is 0.67 times the mass of Jupiter, and D is 0.61 times the mass of Jupiter. Or, in other words, both have masses in between the masses of Saturn and Jupiter. Exoplanet C orbits at an average distance of 1.819 AU, which would be kind of outside the orbit of Mars in our solar system, and its orbital period is 2.78 years. Exoplanet D orbits at an average distance of 6.60 AU, which would be slightly wider than Jupiter's orbit, and its orbital period is 19.2 years. So far, all of these measurements are not that unusual. However, the orbits of exoplanets C and D are rather elongated, which is very unusual for any type of planet-sized object. Actually, the orbit of exoplanet B is also elongated, but like I said before, I'm not going to mention it again during the rest of this episode. The elongation of any planet's orbit can be described by a parameter called eccentricity that varies between 0 and 1. A value of 0 is equivalent to a circular orbit, while a value close to 1 is a very, very elongated orbit that almost looks like a straight line. The orbits of most of the planets in our solar system have eccentricities less than 0.1, which means that they are very circular, although Mercury's is 0.21, which means that it's a little more oval shape, and Pluto's is 0.24, which also makes it more oval shaped, but we knew that Pluto's orbit was weird anyway, and besides, Pluto isn't classified as a real planet anymore. The orbits of the solar system's comets have eccentricities that typically range from 0.5 to 0.999. So, for comparison, the orbit of HT 181433c has an eccentricity of 0.24, which is very similar to Pluto's orbit, and the orbit of HT 181433d has an eccentricity of 0.47, which is similar to that of a comet. That is a bit weird. In fact, the ellipticity of D is so weird that it has been very challenging to properly calculate the exoplanet's orbit. Some earlier calculations of D's orbit had suggested that the exoplanet actually passed within 0.1 AU of C's orbit, which could result in gravitational instabilities in the system, and that would have been unexpected for a planetary system billions of years old. However, those calculations were simply inaccurate. Later analyses demonstrated that C and D actually stay further than 1 AU away from each other. Also, it's worth mentioning that, as of the time of this recording, D has barely completed a single orbit around its host star, so further observations and analyses are needed to properly characterize its orbit. Overall, the HT 181433 system has been an excellent example of how some exoplanets might have really elongated and unusual orbits, and it has forced astronomers to improve their techniques for measuring orbits. The lessons learned from HT 181433 should lead to fewer false alarms about unstable planetary systems. Additionally, I think the really elliptical orbits of these exoplanets might have some sort of implications for what was happening in the star system when its exoplanets were forming. It seems to me like it would be a bit difficult to get a really elongated exoplanet orbit like D's orbit without some sort of gravitational interaction or collision or something else happening during the planet formation process. And I would be interested to see some sort of scientific analysis of this published in the future. So that wraps up my summary of the red dwarf HT 181433 and its 3 exoplanets, one of which I definitely will not mention again in this episode, and the location on the Earth's surface corresponding to the position of this star system in the sky is about 37 kilometers from Adelaide Island, which is near the Antarctic Peninsula. As you would imagine, this offshore area gets a lot of sea ice in spite of global warming. But it seems like it's possible to reach Adelaide Island by ship during the summer, as the island has research bases located on it. You can reach the website for this podcast at www.randomastronomicalobject.com. You can go to the website to read information about the astronomical objects, view images of those astronomical objects, look up additional reference information, and send me random feedback. The audio was recorded and edited by George Bendo. The music is Immersion by Sasha Endy at www.sasha-endy.de, and the sound effects are from the Freesound Project at www.freesound.org. Thanks for listening.